All right, so we're going to look at phase shift today. Phase shift is a fancy word for translations left and right, and we use it specifically when there has been a change to the period of your function. So normal, sine, and cosine have a period of 2 pi. We're going to change that and moved it left and right, so it makes finding things a little bit more complicated, but it'll be fine. All right, so I have two different versions of our equation we've been working at. We've had some where we had a number in front of x where it changed the period. We've had some where that is gone and we're just adding and subtracting from x. We're going to put all of it in the same equation. So if I have a plus sign here, that is left. We have talked about that a little bit. And a minus sign moves it right. Basically, how we're going to figure out how far left and how far right it goes, we have to get rid of the fact that we're changing the period of the function, and we're going to actually factor b out of both terms. So that's going to look a little weird. I'm going to put it down here. So essentially what we're going to do, if you're looking at this equation, if you have a plus sign so it's moving left, your phase shift is going to be minus c over b, using the numbers from here. And what that's going to do is it's going to rewrite the equation, which I'll show you in a second. And the minus sign means left. So if this is positive, that's minus, and it builds in left, so you don't have to actually write the word left. But you can. You could say it moved c over b left. If you have a minus sign over here, that's going to move it right, so we'd have positive c over b. So where does the c over b come from? I'm going to do a little work down below the box. If I have y equals a sine of bx plus c, essentially what we're going to do is we're going to move b out of the parentheses. We're going to factor it out of both terms. But without knowing what c is, you don't know if it's divisible or not. And so you would basically take c and divide it by b. So you still have this b out here that you can use to find the period of your function. And then this becomes c divided by b. So you can figure out how far left or right you're going with the different period of the function built in. It's a little complicated, but it works. All right, so explaining it's more complicated than doing it. Let's jump into an example and see how this is going to go. So we have 3 sine 2x minus pi. The amplitude is still the same thing. It's the number in front of your sine or cosine, so the amplitude on this one would be 3. And remember, if there is a negative, that means reflection, and it doesn't affect the amplitude. The amplitude would still be positive 3. All right, so then if we are going to do phase shift, essentially what we're going to do is we're going to rewrite this equation, and we're going to take the 2 out of both of these terms. So I'm going to take the 2, put it on the outside of the parentheses. So I have x. So basically I took 2x and divided by 2, but I factored it out. It's not completely gone. And then I have to take a 2 out of pi, so I'm just going to call that pi divided by 2. And what that does is it makes it where I can actually see how far left or right I'm moving, and removes the fact that we have a weird different period. It's not a normal parent function. It's been changed a little bit, and that kind of removes that from the situation so that we can see clearly. So the period, you still use 2 pi over b. We moved b outside the equation. It's still the same number that's right here. It's always what's in front of x. So for ours, we're going to take 2 pi and divide by 2, which means that the period is pi. So that means that these waves are going to be happening twice as fast if we looked at the graph. And then the phase shift, if this is negative, that means it's going to move right, or you could just say it's positive pi over 2. So essentially that means it's going to move right pi over 2, just like the translations we did before, but we have to remove this because when you change the period, it affects this number also, and then it kind of messes up. This isn't how far I'm moving. I'm actually only moving pi over 2. So it just kind of takes care of all of that. It rewrites it in a form where we can find what we need. All right, so let's do another one. So on the next one, what is my amplitude?
2.
2. Let's write this equation. So we're going to have 2 cosine. I'm going to take out 4. What's left in the parentheses?
Negative
So x plus 3 pi over 4. Because I basically just divided both of these by 4. But it's not exactly division. It's more like factoring. We just took out this common factor, except it wasn't exactly common with 3 pi. But we made it work. So then how do I find the period?
2 pi divided by 4.
2 pi divided by 4. And we can reduce the 2 over 4 to 1/2. So you get pi over 2, or pi halves. And then, what is my phase shift? Negative 3 pi over 4. And the negative means that it moved left 3 pi over 4. So instead of having to write those 4 letters, L, E, F, T for left, someone decided we're just going to put a minus sign on that, and that means left. Because this is positive, and it's backwards. Plus makes it move left, minus makes it move right. So we put this on the answer, so essentially this sign is going to be the opposite of whatever was in the parentheses. I know it seems bizarre, but that's just how it works. Okay, so now we're going to switch things around a little bit, and we are going to take information and write the function. So on this next one, they tell us it is cosine, which is good to know because it could be sine or cosine. So put y equals, I'm going to leave some space and put the COS for cosine. My amplitude is 5, so that goes in front of the cosine. The period is pi. So to figure out what b is going to be, we have to do a little bit of work. So b is going to be 2 pi divided by pi, which gives us 2. And I'm going to put that on the outside of my parentheses to start with. And then I have x, and if my phase shift is negative pi over 2, that means left pi over 2. When we put it in the equation, we've got to change that to plus pi over 2. So we wrote this in sort of the factored form, and then we can just distribute the 2 back out, and we'll have a normal looking equation. So we'll have y equals 5 times cosine, and I'll move the 2 back in the parentheses, 2x, and then this 2 would cancel with the halves, and we get plus pi. So that's my final answer. So basically, you're taking the information, putting it into this version of the equation, and distributing it back out to get to this version that's a little bit nicer to look at. It doesn't have all those fractions. Okay, let's look at the next one. So I know it's sine and my amplitude is 3. So I'm going to write y equals 3 sin for sine. The period is 4 pi, so I'm going to figure out b, the number to put in front of the parentheses, by taking 2 pi and dividing by 4 pi. If I reduce that, what am I going to get? 1/2, because the pi's canceled. 2 over 4 is 1/2, so I'm going to put a 1/2 on the outside of the parentheses. My phase shift is 3. It doesn't have any pi's on it. This would happen with a lot of real-world situations where we're not measuring things as an angle, but we're measuring things in terms of time. Maybe it's 2 minutes or 3 days. We don't know. And so you'd put in x minus 3 here. So then to finish it off, we go ahead and redistribute the 1/2. Get y equals 3 sine. You can write 1/2 x, or you can be lazy and do x over 2. It's a little bit shorter. And then we can just do 3/2 for 1/2 times 3 there. And that would be my final answer. You could change that to 1.5. Usually they'll leave it like this unless we actually need to find something for a story problem. And then sometimes you'll change that to a decimal or something else to answer the questions, which we'll see more tomorrow.
Yay!
Okay, I knew you'd be excited, my studio audience. Okay, one more. So it's cosine, and the amplitude's 2, but if you look down a little bit, it's also reflected over the x-axis. So I'm going to use this and this and this to get this started. What does the reflection tell me?
Negative.
I'm going to have -2 in front of my cosine instead of just 2. So the cosine, amplitude's 2, it's reflected over the x-axis. Okay? And then the period is pi, so we're going to figure out what b will be. So take 2 pi divided by pi, we get 2, so that's going to go on the outside of the parentheses. My phase shift is pi over 4. It's positive, so when I put it in here, it's going to be minus, so minus pi over 4. So we've taken care of the period, we've taken care of the phase shift, and then I still have it translated up 3. How do I make this translate up 3?
Plus 3.
Plus 3 on the end after the parentheses. So we're sort of combining everything we've learned all into one lesson. And then the only thing we have to do is redistribute this out. So I have negative 2 cosine 2x. I have to take 2 times pi over 4. If you need to, you can make that 2 over 1 times pi over 4 down here to kind of think that through. That becomes 2 pi over 4, which reduces to pi over 2. So I'm going to have 2x minus pi over 2 in there, and then plus 3 on the end. And that is it.